one and all. It gives me an immense pleasure to welcome one and all for the distinguished lecture by Professor Chauhan, Arturo, Falaschi, Emeritus Scientist, International Center for Genetic Engineering and Biotechnology, New Delhi, Distinguished Visiting Professor, Institute of Eminence, University of Delhi on Social Responsibility of Science and Higher Education.
Honorable Vice Chancellor, Professor Gurmeet Singh Sir, distinguished guest and the speaker of this event, Padma Shri Professor V.S. Chauhan, Professor Tarni Karasu, Director of Studies, my faculty colleagues and students. I extend a hearty welcome to everyone to this special academic event of distinguished lecture to be delivered by Professor V.S. Chauhan. The distinguished lecture series is an important academic event initiated by our Honorable Vice Chancellor for the benefit of all of us in the university to be inspired by distinguished academicians and professionals to strengthen our commitment to higher education in our country. We are honored to have Professor V.S. Chauhan today on this forum of distinguished lecture series. Professor V.S. Chauhan is presently an Emeritus Senior Scientist at International Center for Genetic Engineering and Biotechnology, which is a prestigious institution initially established by United Nations, now functioning as an autonomous intergovernment organization, unique in its kind. Professor Chauhan has the unique distinction of having served the highest position in the apex academic bodies of higher education in our country, including as Chairman of University Grants Commission, Chairman of National Assessment and Accreditation Council, and Director of a governing body of Higher Education Funding Agency. We are really honored, sir, to have you with us for this guest lecture series. So with these words, I once again welcome all of you, especially Professor Chauhan, to this event. Thank you.
Now it is time to felicitate our guest of honor, Professor V.S. Chauhan. So before doing that, let me give him a brief introduction to him. I think Professor Pandian has already given introduction to him. So Professor Chauhan, he has obtained his MSc, BSc, MSc and PhD in organic chemistry from University Delhi, and then he went on to do his Rhodes DPhil as Rhodes Scholar at in Oxford University, and after the postdoctoral stint in University of Georgia, he has returned back to India and he joined St. Stephen College in Delhi, and then later he joined as assistant professor in Indian Institute of Technology, Kanpur. And in 1982, he joined University of Delhi as reader and became professor then. And later he joined International Center for Genetic Engineering and Biotechnology in Delhi, and he has become the head of the Malaria and Structural Biology Research Group. And he became director of the institute in 1999 and retired like that. And now he is the Arturo Falaschi Emeritus Scientist at ICGEB and Distinguished Visiting Professor, Institute of Eminence, University of Delhi. So coming to his research, he has vast research, and his field of specialization is peptide design and synthesis, malaria immunology, subunit, vaccine development and malaria drug development. He has published more than 270 papers in international journals and journals of repute, and he has held prestigious positions, as well as he is awardee of, as Professor Pandian has told, he is awardee of Padma Shri, And with this brief introduction, I request our Vice Chancellor to honor our guest of today with a flower bouquet.
Very respected Professor V.S. Chauhan, Professor Pandian, Dr. Thani Karesu, and our Registrar, Dr. Bhuttani. Let me tell you, my role here today is more of a ceremonial role, that I deliberately said that I would be there to say a few words about Professor Chauhan, because routinely what you have heard is, that is on the website, everybody knows him, because he is into practically all kinds of committees related to science. And he's a long experience, he's a wonderful educational administrator. And by virtue of that, I suppose you go anywhere, they will know Professor V.S. Chauhan, in terms of his research, in terms of his credibility, in terms of his contribution to awarding research projects to various bodies and deciding on funding. One part which you will all appreciate, and I was telling him yesterday, I think we owe a deep sense of gratitude to him for that. He stood by whatever he said. That 7th pay commission which was awarded to all of us, all teachers across the country, goes to his credit. He stuck that this has to be given, and there were attempts when they wanted to scuttle it down to some lower level. He wrote that report when he was recovering from some ailment, which, is part of our life. But then he said he's going to finish that, and he put in a concerted effort and completed that. And despite oppositions from many quarters that, this is a little too much for teachers, he said, nothing doing. This has got to be given. So that's where I said we owe a great sense of gratitude to him. Whatever we are living comfortably, we are enjoying the benefits of a good salary package. The credit goes to Professor Chauhan. Then you'll say, why did I express that I will be introducing? There are reasons. Yesterday I said that in chemistry department, but very briefly though. He started teaching at St. Stephen's College at a very raw age of 21. And in his first year when he joined, we were the students who started first year chemistry honors. And that was a time when chemistry honors moved from department to colleges, and that's where we started our career, our journey in chemistry under his guidance. He used to take our theory classes as well as practical classes. The other part which I want to tell you is that if somebody wants to pursue one's own interest, there is no limit, there is no bar. He was a long distance runner and a good sportsman. He would run from a distance of about 11 kilometers plus in the morning to take a class at 8:40 in the college. And he would be having his sports gear, and he'll straight away come there, he'll be sweating, but then he will start not the way we do it with our laptops and projecting the transparencies and reading from that. If you take that thing out, probably one is not able to speak even for 3-4 minutes. But he would just take a chalk and start teaching. That used to be his hallmark during those days. And apart from science, he would encourage us to be an active sports person also. This is second part of which goes to his credit. And after first year of his teaching, he was awarded with Rhodes Scholarship, which probably some of you may not know. It's one of the very prestigious fellowships of our country. Then from there he went on to do his studies in Cambridge, came back. He was invited to join IIT Kanpur, which probably he'll tell you. That was the first time, I suppose, when IITs invited somebody to be on their roles. And from there he came back to University of Delhi as associate professor, where I was a researcher at that time. And the best part is, whenever we'll go to him with any problem, he would never say that he's very busy. He will say, just sit down, let me see how we can work it out. And in a day or so, some solution would be there. And the other good thing which I want all my science teachers to inculcate is that whatever used to be there in his lab, what facilities, he would always say, you can always use this. Even the lab that he headed, that United Nations lab, ICGEB, there also, if anybody would go, he would welcome people to use those facilities. That's what we need, and this is what I've been highlighting all over, that the key to success these days in terms of science, and if we have to really make our universities very vibrant, is that we have to start sharing our resources. Scientific equipment are very expensive, so rather than everybody pushing in for every equipment, we should start sharing our resources in terms of these and in terms of library resources that has become equally expensive. So that was another wonderful part which I thought I'll share with you about Professor Chauhan. And subsequently after that, we also joined the department. Then he became professor and moved for his postdoc to many other universities. He's got a rich experience of science, research in protein, peptide, when it was in the formative stage. This is what he highlighted in chemistry research. He started that at a time when our department, at that time, in late 60s and early 70s, we had one NMR which was 60 megahertz and 90 megahertz, nothing else. All these FTR NMRs and all came much later. From that point onwards, he's developed into DNA sequences, peptide synthesis, and into whatever wonderful work he has done, which has resulted in 270 papers, all kinds of awards in science, membership of all academies, not here, elsewhere also of other countries, and the social award that our government gives, Padma Shri, ultimately, which came his way, which is a result of his untiring effort in promoting science, research, and education on a wider front in our country. So therefore, kindly give a big round of applause to him. We are truly grateful to him, and I've been requesting him to come to our university, and that also you might be surprised. It has come after a relentless effort of about 2.5 years or 3 years. In between, COVID came in, and then, well, finally he's here, and he expressed his desire when I was discussing it with him a little while ago, that he would like to have one talk for all young faculty members who have joined recently. Along with that, all research scholars. He will have one-to-one kind of an interaction where he will listen to them, listen to what they are doing, and would give his piece of advice to wherever, whatever is possible. So we welcome him here, and hope that he'll join us again for the second round of talk, which will go a long way in promoting science research in our university, and this will inculcate a right habit of research for everybody. Thank you so very much for joining us.
Good afternoon to everyone, and thank you for very generous introductions. Gurmeet is absolutely right. We've been trying to do this for past more than 3 years. Either I've been busy or Gurmeet is traveling. But when I met, I see Gurmeet off and on. As he said, that I taught him actually 51 years back. I wonder how many of you are 51 years old in this room. But when you meet someone like, we knew Gurmeet was an outstanding student right from the very beginning. And I'm not going to talk too much about your Vice Chancellor. But when you see the kind of work your students you've taught, I'm sure you will feel this as you grow older, if you're in education. You feel extreme, great, warm sense of pride that all of us who do decide to teach, especially those of us who came back in 70s and 80s in tough time, I think reward of what I feel we've done, whatever little we've done, is the having a large number crop of people like your current Vice Chancellor. So I think that gives some sort of satisfaction of something we've enjoyed our life. for the talk, and I'm very happy to be in Pondicherry. It's one of the finest city, and the smallest chance I'll get, I'll always come back to this city. What I thought I'll talk in general, so this is not a technical talk, there are three parts of what I'm going to share with you, and I'll just do it very briefly, so I'll leave it for discussions if anybody wants to raise an issue. And what you heard, yes, I was chairman of NAC when NAC was really needed to be transformed. In fact, there was a discussion earlier on that NAC should be closed and some other vertical should take over. And that's the time when we had to look back. So NAC or NIRF or new education policy, equivalence, which part of new education policy is difficult, if there is an easy part, do we need more money, what the National Science Foundation, what NRF and so on. I'll be happy to discuss that now, today or next time or informally, whatever. But for the structure, what I'm going to talk about is in three parts. There has been a tension for past 20, 30, 3 decades. I mean, advent of internet and so on. But the money is for research, and this happened over a long period of time, but it peaked in 1980s. This is when Margaret Thatcher and Ronald Reagan were running USA and one was running UK. And the amount of money that was in higher education from the state, and very quickly I tell you, before that universities were funded entirely by states. That's a German model. All German models still followed, Scandinavian still follow more or less, but the money became short. And what at least she did, the Prime Minister in UK, is thinking that education is becoming something that everybody wants to get, so it's a business. And I didn't think she cut any words. Everybody thought education is a business, should run as a business. So overnight, the funding in places like Oxford, Cambridge, Warwick, Bath, Bristol, King's College, etc., were reversed. Today, as you see these universities, maybe we want to follow some, and India is, I suppose, slowly going that way, was that universities had to look for themselves. So that's one idea that I thought I'll mention very briefly, because higher education itself has gone into many twists. Universities were never supposed to do the ranking of themselves, for example. Universities were never asked the question that are being asked. Universities are not responsible for finding jobs for those who came to university. All these things are only 30 years old. Placement offices, etc. So those of you interested in history of higher education, you would find before 80, so when IIT started on the front page of a newspaper saying that a package of 40 lakhs or 30 lakhs, this is a recent phenomenon. It didn't happen like that. When Gurmeet was a student, it didn't happen like that. So anyway, so university themselves are gone. Then the science, when the DNA was, structure was revealed in Cambridge, and followed that, when biotechnology, what we know as biotechnology, biology took over. So there's a great time in physics in early 90s, when Einstein, the whole lot of them, all of them in 20s in Vienna, in England, physics had a really high point in 20s, 30s. Soon after the war, the chemistry took over, and then the synthetic rubber, plastic, all that you see around, that was the golden age of chemistry. Everything was taken over by early 70s by biomedical sciences, because health became a major issue. People started living longer, we knew more about immunology, and now then after that you have immunology, nanotechnology, and so on. But recently, in past 3 years, the whole world stood silent almost for 3 years. And everybody started looking at science, and science has solutions for it. We've looked at science for economic growth. The countries that have invested huge amount in science, like China, Germany, are reaping benefits of, they're economically very strong. So there's a great connection between economic or other strengths of a country with the amount of money that you spend in science. And there are huge papers written about it. But word over when COVID, this little virus came in 2019 December, announced on 31st of December, everything stopped. All the solution, how do you will diagnosis, we didn't know what the virus genome was. Everything moved very fast. So people went back looking for science. So I was mentioning to you that if science is omnipresent, if science has responsibility everywhere, and if you look at this, I don't want to give a very long lecture. There is nothing that happens around us today. It wasn't so 200 years back, but nothing that happens around us where science is not involved. So in the big blob that you see whatever, travel, tourism, economic, immunology, whatever you do, you'll find science. So if science is so omnipresent, society looks to it, but society has in return any responsibility. First of all, does science has any responsibility? And the past 10, 15 years that we've seen with the social media and so on, we are now living with a problem of bad information, fraud in science, unethical, not moral science. So I think some of these things I'll cover. What I'll also try to cover is how do teaching community is responsible, we are all responsible for, or are we followed by any ethics? Do we have any moral responsibility? And that's a big word, but do we have any moral responsibility to our students? And finally, something about higher education. What should higher education be doing? So let me just quickly move on with this. So science and society, science is just actually is understanding nature, always has been. It continues to be. If you want to find out what Alzheimer's disease is, basically you're understanding nature. So all this is understanding nature. Science is evidence and its evolution of science is always based on it. It's a seeking truth. In fact, not so long back, the scientist word is not very old word. Scientist word itself is just 250 years old. Before this, people, what is a scientist? You walk around, you look at something moving or static. You just want to find out how it moves, why it moves, where it moves. This is why rose is rose color, why this is black color. All this will be just natural curiosity. And when you satisfy this curiosity by asking questions, so science is a systematic way of asking questions to understand nature. There's nothing more to science, there's nothing less to science. So this is a man who actually, you coined the word science first of all. So this is not very long back. So scientists were known to be natural. If you went to Oxford or Cambridge, let's say in 1600 or 1500, there was no chemistry department. There was no physics department. These universities, 1,000-year-old, only taught theology, logic, and maybe social behavior. That's all these universities did for 600 years. It's only when Berlin University with Humboldt, some of you are Humboldt fellow, but Humboldt was the beginner starter of a modern university. University of Berlin is the oldest modern university where research moved into university. But today, what is scientist supposed to do? Scientist joins a university, joins an institution, must produce research, must publish. If he doesn't publish, he perishes. It certainly wasn't like that. There were people who didn't publish more than 10 papers in their whole life, and they're the finest scientists. So much has changed. So pressure on being a scientist is also becoming extremely, extremely high. So I want to just raise this issue now. So for past 50, 60 years, I have mentioned to you, most of the money in 70s started going into biology. DNA sequencing, how to cut a bacteria, how to produce insulin, how to produce drugs, everything, how to produce vaccines, how to genome sequence, how to look after cancer, and all that. But the questions were beginning to ask all over the world. I'm talking about past 30 years. That if you take money to do this thing or we invest, what do we get out of it? You will hear this very commonly. Those of you a student here, when you start your career, this will be asked of us, all of us. We give you 50 lakhs, we give you 2 crores, you start your research, what do you get out of it? This question has become so common that we don't even think it's a wrong question or a right question. I think all of us are so sucked into it. So if I work with malaria, for example, and I want to look at parasite biology, I'm only interested in looking at how parasite enter red blood cell, but that's not good enough. Certainly not good enough for us, for an agency which is going to fund me. He said, thank you very much, you want to find out, but what do you produce after this? So all I want to say, this debate is not a new debate. We think it's a new debate, it's not. So this is a man who wrote a very large number of books. He's the one who brought this idea of social function of science. Just a 30 seconds on him. He worked with 3 Nobel Prize winners. You can see the name Dorothy Hodgkin, has been very outstanding mathematician. Lived through 2 World Wars. First World War, he was a young man. Second World War, he's an old man. He's a what you call today the leftist idea of life, and said very clearly, and wrote many books and argued very coherently that all research, all science research should have a political way. What he meant by political overtones is that science should only serve this. Whatever science does must be for the service of society. In other words, you can't ask a question or should not ask a scientific for the sake of asking questions. We did I have done a lot of work where we were not solving any problem. We were just asking a question. So this is very strong voice in 20s, 30s. You were very friendly with Russians. Russian policies, that Russian science was very high, and he influenced Russian science enormously. He was very friendly with Russia. Bernard Len, those of you interested in history, science in history, I think you have to read Bernard. Fortunately, at the same time, there were another man, lived about the same time, the Hungarian. He was physical chemist by training, finally ended up teaching economics at Manchester University. An amazing man, also wrote very large number of books and argued at the same time. There are BBC debates of these two on radio. And I'm talking about late 40s. And they would argue, and he was clear that science is when few experts who know what they're talking about. Like imagine physicists sitting in this room, 6 of the Nobel Prize winners, they just talk. That's what I was telling Gurmeet, that next time when I come, we just sit with younger people, older people are welcome, and we just talk. Let's see what emerges out. So according to Pauliani, was that you just have discussions among them and new ideas come. I can give you 100 examples. Diode array, monoclonal antibodies, many problems. They have just came from discussion, why can't we do this? You do this and you found an amazing thing. But he also indicated at the right time that if I stand here and say something to you with great sense of authority, that look, I'm telling you this is black, or this is not black, this is red, and expect you to agree with me that this is red and not black, or dark red, not black. He said that this is dangerous for science. So positivism in science can be extremely dangerous. I'm sure by now you've read, I'm just quoting him. It was very relevant because science was going that way. And he also wrote very large number, but his son got a Nobel Prize. He worked, Michael worked in chemistry, his son. Then the evidence of what he said is in this man. The man is Lysenko. If you go to Google, you can even Google Lysenkism. Lysenko and Bernal were great friends. And Lysenko was a very good scientist, but he said that he would let you believe that this is green and not black. He influenced Russian science so much that Russian science actually in genetics never recovered, even till today. And he was responsible for a large number. He didn't believe in Mendelian genetics, which all of us know that was true. He has his own ideas. He influenced, Russians were controlled like this at that time, and he influenced that Mendelian genetics is of no value. And that amounted to the death of more than 4,000 Russian scientists. Either they were jailed or they were killed. So positivism in science, and I'm using this in a generic way, positivism in anything by anyone could have good things, but could have very serious consequences. In science, that was exemplified by Lysenko. So to summarize this part, the debate that the science should only do things which serve society is one idea. Second idea, the science should be left alone, should not be influenced by anything except for just asking good questions. And whatever then comes out is always useful. There's more evidence of this than of that. And finally, in science, nobody, whether it's me or Gurmeet or you, should have the last word, that I know better than everybody else. It doesn't work. Science doesn't. Science needs evidence and proof. If you bring evidence and proof, you're welcome. So, after that, I just want to ask the question, can society and science play a role in, should they play a role in policy making? They play a role in policy making all the time. How much role should they play? We have different examples in different countries, but countries which invest sufficient in higher education, and for example, your space research, your atomic research or whatever. So I think that becomes very important. Then the question is scientific facts versus society's perception. This you saw in COVID time. I can take many examples of the past, but COVID will be very good example to take. There was so much of which vaccine is right, who's producing this vaccine, this is Russian vaccine, this Chinese vaccine, this vaccine doesn't work, that vaccine doesn't work. So society perceptions get completely clouded by this barrage of whether it is virus that came out from a lab in China, whether it came from bats, if it came from bats, where is the intermediate animal, and so on. So sometimes science gets completely diverted. If scientific facts get distorted, with hydroxychloroquine works for COVID or not, WHO is saying something else. So I think those are the danger, and I think we need to figure out what are the needs. What is society's responsibility? And I take an example right now. That example will come a little bit later. But today, if you ask me, what is in health sciences in India the biggest problem? I mean, COVID is still there in some sense, and all of us are hurt in COVID one way or the other. Either we lost some people or we ourselves got COVID. But if you ask me tomorrow what is facing us is the antimicrobial resistance. We have talked about this for past 20 years. International discussions have taken place. India and China and Bangladesh are threatened. The new antibiotics will not be available. So the problem of antibiotic resistance, can society take care of this? And I can give a separate lecture on this, where in some of the tuberculosis, for example, India still has, after so much effort, 1/5 of all tuberculosis, 1/4 of all tuberculosis cases are in our country. Despite our Honorable Prime Minister having announced that we should get rid of it by 2025, we still have 20%. I think these things society, if we communicate properly to society, these cannot be taken care of without role of society. For example, doctors, GPs form society. They are part of society. Should they give us antibiotic for every small flu infection? Or should we, at least as educated, should we take full course of augmentin if we have influenza or have a running nose? And unless that kind of discussion take place with society, science will end up taking a second stage. We have right now, as I speak with you, no answer whatsoever for antimicrobial resistance. So if I get a chest infection and I'm 70 years old, the likelihood is that none of the, and if it's a bacterial resistant strain, likelihood that none of the antibiotics will work on me and I'll die a death which is quite painful death. So I'm not painting something which is future, I'm painting something which is present. So society will have to, so these are the tension society can take care of this. So as I said, society can directly look at vaccination, for example. There are groups, 1/3 of America did not get vaccinated by COVID vaccine. And that's the country which is highly educated, more vaccine than anywhere in the world, Moderna, Pfizer. But fact is, 1/3 of America never got vaccinated. So is this society's responsibility here? That if I get infected, I might infect you. So if I don't take vaccine, I take the responsibility of infecting you also. And so I think these are the issues that society can very easily take care of. Now, we know that there's something called Crispr. Those who do social science here may not have heard of Crispr, but you've been hearing about genome editing. It's the most powerful tool in a molecular biology in the last 20 years. I think cutting off DNA earlier, whereby you can produce insulin and gamma interferon and so on. But today, perhaps the most powerful tool in the hand of a first-year biotechnology student is something called Crispr. So Crispr is a small RNA. I'm not going to tell you the detail, but take it from me. You can edit genomes of whatever you like. So if genome is this long, and we wanted to make a change earlier, it took us 2 years to do a site-specific mutagenesis or whatever, test it. But today, with this tool, you can just go and make a change right here. And for example, sickle cell disease has a single nucleotide. Will society benefit from it? If you can get into the fetus or in your spleen and make that change using this tool, you can in principle get rid of thalassemia, you can get rid of sickle cell anemia. But since you can do this, you can also do a huge amount of damage. That's where society comes into the place. Society has to be, if not taught, has to be made aware of what are the dangers of this. That's why higher education becomes very important. This should be part of education, that there's no invention that I know in science which can't have a negative effect. All, whether it's internet or nuclear power, would have. So society has to build pressure that look, we should do this, we should not do this. And those forces must come from society. So that's what society can do. Misinformation. I think amount of misinformation that, by the way, bad information and misinformation always spreads faster than good information. We have enough evidence. Bad news or bad information will get into the internet viral much faster than good quality information. And we saw that in COVID. There was a huge amount of confusion caused by bad information. That's where society again has to take care of. Now my second question, and I address young student and faculty which have a scientific career. There is a second part. That's fine. We create knowledge, tell society. What about scientific integrity? And the past 20, 30 years, because I said today's scientist, what is today's successful scientist? Get into a job, publish, more you publish, higher you get, and sometimes you forget in this race that you might be dropping your standards a little bit. And I think that has become a serious issue, and this is one of the things that I'm currently involved. In fact, you all heard of UGC care list, all of you? You publish in Scopus. In fact, I chaired that committee very reluctantly because I don't think we should tell people in higher education how to behave themselves. If this group of people do not know how to behave themselves or what is sense of integrity, you can never teach them. But still they were pressured, we should have a... Why was this built up? So I'll give you an example. That's not from our country. I've just taken an old example, but it's a famous example. Two scientists, one Korean and the other one is a Chinese. And let me go to the bottom one. This girl worked in Riken Institute, one of the best institute in Japan. They were way ahead of everyone in stem cells. You've heard of stem cells, I'm sure. And it's gone up, it's not so much talked about, but stem cells, now we know you can take a cell out of my skin. In the lab, a skin cell can be converted into a liver cell or a kidney cell. Now we know it can be done. But it took long time for us to understand how to do it. So yes, from skin you can make a liver cell or kidney cell. But then when they published this came in a journal called Nature, back-to-back 2 papers. Looking back, it was such a stupid idea. They gave that in a petri dish, you put some salt, you shake it, and you'll get stem cells. Of course, that was not true. And in 2 weeks, all the labs said it can't be done. So why would a top institution, top scientist lab, Sasaki lab, would do such a thing? A lot of us asking that question even today. What would force us? Finally, the Riken Institute created a company. Riken Institute, by the way, is one of the top institutes in the world. Its image went down. One of the when Sasaki committed suicide, he was one of the most successful scientists. So there are pressures on scientists. Sometimes we don't understand. I think those of you in the crowd will do science or publish papers. I think this little sense of integrity in science will go a long way. Lack of integrity of science. Another example, there are many, Italian example, German example, not to mention many Indian example. Society begins to lose faith then. And once you lose the faith of your client, then you just destroy the faith. So the building of faith takes very long time. And scientists or researchers sometime in a hurry could damage, if not destroy, could damage. So the continuous dialogue of good quality work, continuous eyes on what you teach your student, put a sense of integrity in your own research labs. And this is going to be under tremendous pressure. I'll come to the last part of my talk. What I'm saying, it will come under tremendous pressure. It's already under pressure. So there are people. So why, when I chaired 7th Pay Commission, I forgot to tell Gurmeet that, and one of the things we did in 7th Pay Commission, the first thing, of course, salary, etc. had to be raised, that we destroyed API from colleges. That all of you, I'm sure, remember your API, attend a conference, you get a half a point, do this, you get 2 points. There was so much of fake data was being produced by academics at that time. And society outside, because we are part of society, were laughing. The whole world was laughing on the API in colleges. You do 10 points, you'll get this promotion. 7th Pay Commission report destroyed that API. Still is in university in a much more manageable fashion. But how do we promote people? how do you induct people? What sense of integrity you have when you're hiring people? I think that becomes, sometimes we ignore it, but this is the huge challenge and biggest responsibility on all of us who are in this business, because that's the bedrock of future of higher education. And I think we have to just get that confidence back of society, that we are not in the business of fixing things in our science, in our teaching, in our promotion, in our hiring. All of us need to search our heart. And my own personal view is, if I want to go and teach and research, I should want to do it. If I don't want to do it and I have to cut corners when I come to education, then I think the whole plot is lost. Nobody should come to teach if you don't want to teach from inside. And if you come to teach or research, it's the most pleasant job you can ever find in the whole world, because you get paid for something that you seriously enjoy. This is my message to the younger people. So these are not examples from India. These are famous examples of people who committed fraud. Some went to jail. Some went to jail for doing unethical research. There's a Chinese scientist who just came out of jail about a couple of months back, who used CRISPR to produce a baby when the fetus research on CRISPR was completely banned morally. I'm talking about real time now. He produced two babies. When this was banned, in fact the whole world was said, society was said, let's not use CRISPR as a tool to do anything with the human genetic. He did, and in China, of course, a lot of people were doing, but he published, he got caught, and was sent to jail in China, just came out. One of the finest scientists. So morality is also very, very important. In fact, I feel really sorry for Sato, because he was really, really good scientist. And I purposely took example from some of the very highly developed countries, that it's not that it happens only this is disease all over the world. So ethics in science already talks about science. I mean, if we are a bunch of scientists, our job is to get into the lab, look at a problem. We can't tell how the science people should look at science. That's the job of politicians, economists, and so on. So we scientists can only look at whatever is possible and how it is done. After that, I think science take over. I was giving an example in chemistry department, mRNA vaccine. A woman in Philadelphia who first thought of that mRNA can be used, never thought there will be a mRNA vaccine. She just showed that mRNA injection in animal could give you protein and raise antibodies. That was done 20 years back. But whether it will go into Pfizer or Moderna making vaccines, so science, that's not science job. Science and society, I've said it enough, have to work together. So I'll move on and try to finish this. This has gone for about 40 years now. Activists, whether they're animal activists, whether they are activists of against vaccines, are very, very famous in the last 40 years. I can take an example. All animal experiments, for example, on monkey. Of course, scientists were doing some very poor quality experiments on animals. But if you did no animal experiments at all and banned it all over the world as some active, then you would not have the COVID vaccine. No vaccine, no drug of any kind can ever get into humans unless you test them for safety. I mean, that's the bottom line. Even activists will not take a vaccine if I bring straight from the lab to the activist arm. So here sometimes I feel, and I felt over the years, and I follow this, the scientists do not speak the language they should speak. That is what I am saying, right, humne kaam kar diya, this is our work. It's up to you to understand. So activists and scientists should actually engage with each other. First, scientists should engage with scientists. Many times I find scientists are not on the same page, many times, on many things. Like genetically modified food or crops in India, even scientists are not on the same page. The result is we have, after BT cotton, which came not through the front door, we haven't had anything. Bangladesh has brinjal, which is BT brinjal, or many soya beans and so on. China, 50% of all Chinese produce is genetically modified. So genetically modified is not a bad name. How do we tell the society it's not a bad name? Who does the explanation? The scientist has to communicate better than it does. So misunderstanding, mistrust has to be removed. India, unfortunately, is still developing in that stage that there are no strong common voices where these two parties can be brought together. If you go to ISC for a debate, either you'll be very loud voices on this side and maybe some voices on this side. But there never these two meet. In other major countries, there are now forums where the scientists always, you can see how many scientists write good articles in the press today. You can count them on your fingers. Scientists think the job is only to do research. The scientists should write, should disseminate, and write in a language that is understandable to society. Society should seek out such people, and society should seek good information, not bad information. So I think this bridge needs to be built. Now the last bit about the higher education. So one question, what is university for? I raised it at the beginning. I told you what universities were for. You went to university, you met different people. This is what campuses, Harvard or Oxford today will claim, or St. Stephen's College or Pondicherry University. You come here, you are taught, and you make friends, you take lifetime impression, and hopefully you take some values from your. But universities are being asked to do much more. Never been asked that before. As I told you, find jobs for kids, have a placement cell, participate in NIRF, get ready for NAC. So I think university is also being distracted. My own view is university is to educate people, not to skill people. Actually, skilling business is nothing to do with university education. If you come to read chemistry at Pondicherry University, of course you will learn chemistry. That's part of your skill. If you want to do economics in Pondicherry University or Delhi University, of course we'll teach you economics. That will be part of your skilling. The rest, to me, education is how you talk to everybody. Do you learn patience to listen to someone? Do you interrupt people? That's good education. Do you wait for people to get into the bus? Or you wait before you get into a lift when people come out? I think that's part of education. It's not etiquettes. It's just social behavior. That you should learn. That should be taught in school. That should be taught in. Do you carry any moral values from here? Do you get the sense of what is right, what is wrong? I think that's what university job is. And I think sooner we look at that, then better it would be. What are the expectations from the industry, what we can deliver? I think we've already discussed this. So there are three major stakeholders, and I'll just wind up now. To me, the biggest stakeholder in university education is student, and should always remain the student. Second biggest stakeholder would be faculty, parents, those who invest money, those who teach. Now the third major, the society. Society should take people become IAS officers and IPS officers, some and so on. There is another vertical getting created right now, which is technology. And I think I'm going to wind up because I think we started a little bit late. The real challenge which started somewhere in 1990 when the internet came into being. See, the ranking, if you remember, international ranking, it only started 2007. There was some joke ranking in Oxford, Cambridge colleges, but business of ranking came up because of internet. So then Scopus, that the media houses become publishing houses become so large that they are forced. Elsevier's, and I don't want to name Thomson, a whole lot of them, Springer. Control, that's the third power in knowledge. I dare say knowledge, even knowledge creation. The way knowledge is created is so different now. And I hope I'm not raising a complicated issue. So I'm just dealing with, I was in a G20 meeting last week, where the serious concern that already publishing is controlled by very large groups, monopoly. Big tech getting into knowledge, I wouldn't say creation right now, but knowledge dissemination, which will be your chat GTP. I'm sure all of you, if not used it, you hear about it, that the already pre-generated database. So in early March, a paper was published in Nature where 100 paper abstracts were written and submitted to people like us. 68 of them we could not recognize were written by machine or written by humans, as much as 68%. So is this the way knowledge will be created? Will a student ever write a tutorial now in Oxford? Or will the computer with the fourth power, and that won't be publishing houses, I assure you. That will be big tech, it will be Microsoft, it will be Google's of the world tomorrow. I think we collectively have to figure out how far this should be allowed to go. I see the dangerous side. A lot of people have said that good things can come out in biomedical sciences. This is something that's happening in front of us right now. So chat GTP4 can actually, I can write an abstract in even local language, in Spanish, and in real time I can get converted, corrected, grammar corrected in English. How much of that will come on our tables for future? How much will that be correct or not? How much will that be fake? How much will that be fraud? Only time will tell. How will we deal with it? I have absolutely no idea right now. But the knowledge creation itself might be under danger. Or the human creativity vis-a-vis putting pen on a paper or asking a question on a board might itself be threatened. A lot of people say a lot of good things. For example, if Gurmeet wants to, or you want to synthesize a molecule complex, you can go to GTP. It'll give you, it will today with the another software will give you the best synthetic route without you and your students ever discussing it. It'll also give you the yield. This much, if you do this, you'll get. This is already happening. But will it take the fun of science, the creativity out of our life? I think time will tell. We should not be tempted to buy mind. Temptation will be very big, no question. And like, if I want to do anything, just Google it. But Google right now tells you to go to this paper, some are allowed, some are accessed. I'm looking at, for the country right now, I think I can reveal this. I'm chairing a committee where we are looking at open access to all journals to everyone in community. Everyone included here. There's a Government of India project. But this itself come under threat with the GPT engines. So challenges in how do we measure, or how will we measure whether you've done good science or you haven't done. It's already a problem. So the number of papers, I published 270 papers. Is that very impressive? Or somebody has published 1,000 papers. In fact, day before yesterday, there's a chemist, 110 papers in 1 year. 100, that's it, one paper every 3 days. And that's a news. So How do we deal with predatory journals? I think we can put hand on our heart, all of us. When are we tempted to publish fake data? I say this very clearly to especially the younger people. The lessons we have to learn is to keep integrity of higher education and science in mind. You do little and you'll always be recognized. Let me assure you this. You remain integral to your job, recognition will always come. It might be a day later, but just don't get tempted. But right now, what is on the slide you read, this is a serious issue. If a university NIR ranking will go up because you have many more publications, I see this in private institutions all the time. While we were doing NAC, I was against this idea of putting too much Scopus research paper in. So that was my personal opinion. And that's exactly what happened. Large number of predatory journals have entered into these. Well, they all say they are peer reviewed. The moment they are peer reviewed, they are in the UGC care list. They are in UGC care list, you publish them. Pay 5,000 rupees, your paper will be published in 3 days. Peer reviewed. You can see, I'm sure you all get solicitation all the time. That submit your paper, it will be published before 21st of June and so on. That has to be killed. That enemy has to be murdered completely. The only way to kill it, murder, is to go back to policy decision. How should we recognize quality? How should we promote people? So I think these are very serious points. I've already said that. So I'm going to stop here. So finally, I just wanted to say this to you. Science will be asked questions. That whatever you do, if I give you 10 crores, where is the vaccine at the end of it? I think policymakers, funding agencies should not be trying to solve big problems all the time, grand challenges that way. We don't have an HIV vaccine. After 25 million people have died of HIV. So just because you give me 1,000 crore and say HIV vaccine should come, it doesn't mean you get. We don't have a dengue vaccine. We don't have a vaccine, successful vaccine for malaria. We are very, very good in science. We don't have a vaccine for tuberculosis that works. So it's not just seeing money is here, give me the solution. I think a lot of science should be done, trying to understand why we don't have an HIV vaccine right now. More money has been spent on HIV vaccine than anything that I can think of. Cancer still remains a problem, no matter what we claim. So science has to ask this fundamental question. Second, science must take society with it, and vice versa. Scientist has to get to the society in a better way than it does. Once it gains the society's confidence, I think social pressure should be built on funding agencies and the let's not hurry up thing. Finally, in higher education, if integrity in higher education lost, let me assure you, everything is lost. If we as a community start cutting corners, I think that's the end of higher education and faith in higher education. You go to any TV channel in the evening after 7, see how highly educated people with foreign education cannot have a decent conversation. They would stop each other, they shout at each other. Louder they shout, better they think that's bad education. And I think we should not get that path. So thank you very much.
Thank you, sir, for such an interesting and inspiring talk, which is very relevant in today's world. So now we can interact with the speaker.
We have started neglecting mathematical sciences. We have started paying more attention to the other related areas. My own opinion, which I have been expressing everywhere, that maths is a very important subject, and everybody, including biologists, if somebody is a good mathematician, one tend to do very well. Not only in his own domain, but elsewhere also. Only we need to pay a little more attention on that.
See, that's why I said what are universities for? So what had happened, and I just not say I put maths as a pure joy in science, maths at the very top. Physics and chemistry, astronomy and so on will be applied. But maths is magic. And the trouble with maths, even in places like ICERs and so on right now, is that every parent is investing money in America or something. It costs you $100,000 for 1 year to do law at Harvard. So you look for return for investment immediately, and nothing you can do about it. If I send my child to London School of Economics, I want a job immediately. Mathematics has gone out from job creation. So that has affected, but math, as I said, after maths and physics, all your backroom boys of financial world either are mathematician or physicist. But obvious jobs are not there. So that Gurmeet is a problem. But I think we should not keep our eyes off from teaching good mathematics. Even if you class of 20 people, if we can get 4 kids taking interest in maths, I think that will be wonderful. Unfortunately, university got tied up with the job market. And that seems irreversible right now. Because the cost of going to Oxford, Cambridge, Imperial College are so high that every parent or kid, that's why MBA became so popular. There's hardly any, I'm not saying MBA should not be taught, business management shouldn't be taught, but the jobs were immediately available. So a lot of people got drifted. Same for law. National Law School, Bangalore, then Nalsar, then Jodhpur, then Raipur. Then every state has a National Law Institute. Every private university teaching law. So some fundamental in science, some things have been ignored, but I can see the pressure. That's why I say society has to. If you find your kid, your son or daughter marginally interested in maths, please nurture that. Don't push that child into this or that. You become a doctor, do this. If you see any small roots or small sprouts coming, nurture that tree.
It was very beautiful when you talked about the joy of teaching and learning, and that the real reason to be an educator would be because we like doing it, we love doing it, and our heart and head, the intellect is together. But the challenge to educators is, especially in the context of the NEP 2020, we have a great rubric of how we're going to break these silos and how we're going to integrate subject domain knowledge along with attitude, skills and knowledge which are necessary to prepare us for the future. But you raised a very important, though briefly, you touched upon the fact about little things that we need to learn in life. We could call them values or virtues, which are neglected. So my question to you is, we're mostly concentrating on subject domain knowledge and cognitive knowledge and cognitive learning. How do you envision that at the scale that India works, we operate on, how are we going to transact and negotiate and bring in this understanding and assimilation of virtues of human behavior, intrapersonal, interpersonal communication into any domain knowledge, which you briefly touched upon, and I want to ask you, how are you going to do this? I find it's a great challenge for the country.
As I said, that is something that should worry all of us. And that's why I took the example of television debates, and how badly the anchor behaves so badly, and so does everybody else behaves badly. Now, going back to your question, I think what we would need, I don't know how will we get there, even today. You go to, I'm sure your examples in your own university, you go to a small college, you'll find some teachers, you will just select them, are so much more dedicated than the others. We'll find them in everywhere. You'll find them in IITs, you'll find them in NITs. And let me assure you, I've been doing Rhodes Scholarship, INLAC Scholarship. I'll talk about that sometime, next time when I come. And now Felix Scholarship for 40 years. From 1980 till now, I still run the Rhodes Scholarship. I see each year amazingly, very increasingly better quality kids coming through these interviews. Those kids are actually being taught by you, by your colleagues. They're very well behaved, highly educated, very sharp, and I keep getting these about 1,000 kids which are absolutely outstanding, will get into any university in the world and go and top in any university in the world. Fortunately, our system still produces them. But going back to Issa, I didn't have time to put that slide. I personally think in many things, these are individual responsibility. But I can assure you one thing. Show me a good, dedicated teacher, I'll show you 100 students infected or affected by that teacher. Take me wherever you like. Show me a good, dedicated teacher who wants to teach. I'll show you dozens of students will remember them for the rest of their lives. So I think, again, it's a moral responsibility of us in the teaching business. How should we do it? I don't know how at scale, how would we do it? One of the things which I was discussing with your Vice Chancellor, our moral responsibility is if we have a high position, we try to do that for our scholars, selection every year. Never let the quality go out of the mind. And I think 50% or half of the job is done if you, at the induction level, take people. There are good people available. There are dedicated people available. There are people, and then nurture them. There's no other. This is the problem that you say is all over the world right now. Students have very small span of attention. How do you get their attention? They have 100 ways of learning what you and I are going to teach them. They don't even have to come. We are encouraging them. They don't have to come to us. All those will be future. But still, you sit with students, spend some time with them, you will imprint them for the rest of their life.
Interesting incident. Very recently I met one surgeon, and he was advocating for all the patients who were trained, go for music therapy, go and do your meditation. And in front of us, one aged person, he was just saying, I feel very happy when I come to meet my doctor daily. So I said, what ailment you have? No, nothing, but just to talk with him. Because he never gives me any treatment. Rather, when I want an injection, he'll put sterile water into that and he'll inject me. So what is his social responsibility? Being a very well-known surgeon. Then I interviewed with a surgeon and I asked, why should you do like this? Sir, is it not doing, not justice to your profession? He said, this is also a way of practice. Because I am treating them psychologically. Based on that, they will be recovering. Later on, if they require, I may be suggesting or prescribing Emeritus. So then I understood the social responsibility is there. Treating them first psychologically and then by means of medicine.
Absolutely.
And he said probably he himself is taking alternative medicine. He being an allopathic surgeon, is taking alternative medicine.
Absolutely.
I was wondering a bit, so I just want to share.
No, absolutely true. So two communities. One is doctors, those who look after us when we are ill, and teachers. These two professions, to my mind, have the largest responsibility. Individually behave. You know why some doctors are always people want to go to doctors? Because they talk to you well. They are patient with you. I think teacher also, if student comes, you always find time for students. I've always found time for my students, whether home or this. And student, let me assure you this. What you invest in your student always give you more than what you've invested. I say it with greatest of clarity. They do well, they become better citizen, they are the ones who propagate your values. So I think the impression that a teacher can form on both school teacher as well as university teacher, I think we should just, those of you who are in this room are already teachers and will become future teacher. If we can work at an individual level to better our ability, I think the job is done.
It is my immense pleasure to give the vote of thanks. I wholeheartedly thank our Vice Chancellor, Professor Gurmeet Singh, for taking such initiative for organizing series of distinguished talks to motivate the faculties and students of the university. And I thank Professor Pandian for organizing the talk. And words are too less to thank Professor Chauhan for his wonderful thought and thought-provoking lecture on social responsibility of science and higher education. So in this lecture, he has deliberated on what is science, and he told us that science is to ask questions, and the policymakers should, when they give fund, they should not expect too much out of the researcher, and rather we have to do research to find answers, and not all research will give rise to give in something that is concrete at the end of the research, but you will definitely gain knowledge out of it. And then he talked about the integrity on the another point he talked about is the role of society in science and what science can do for society. And the another interesting thing he discussed is about the he emphasized is to keep integrity of the science, and we should not go madly behind the number of papers, but rather we have to look into the quality of the papers, and we have to do research. And in this one, the role of higher education, that is the university, is to impart knowledge to the students. And it is not that we have to bother too much about the skill development, but we have to inculcate the scientific spirit, as well as they also have to learn about the basic human etiquette. All these things comes as part of this. So we have really benefited out of your talk, sir. And I thank Director of Studies, Registrar, the officers and staff of the university, deans and HODs of various schools and departments, my faculty colleagues, research scholars, students, and one and all present here. I also thank the team members of EMRC, the cameraman, the supporting team from the engineering and electrical wing, and most importantly, the participant. If I missed anybody to thank, it is by ignorance. So I thank you one and all.